Okay, well this blog post is a supplement to my post about Mac flooding at breakstuffmajorly.blogspot.com. Starting out with opening up PuTTY to get into my switch. On my test network, the victim hosts have already talked to one another, so I've got to clear the cam table. And if the hosts have already talked to each other, then this hack is not going to work for sniffing traffic between them. So in a real life scenario, you'd be trying to sniff traffic from two hosts that haven't talked to each other yet. In our case, since during testing I did have them talk to each other, I'm going to go ahead and clear the cam table. That's with typing with one hand here, so my bad, but my real bad. Alright, we can also go ahead and take a look at what our MAC address table looks like right now. I'm just going to take a look at the count and see what we got. So it looks like we've got 8,189 spaces available for MAC addresses, and we're on this VLAN 2 here, so it looks like there's only one MAC address, and that's my attacking host. So everything's looking good for the attack. Now we've kind of set things back to default for how it would look in an attack scenario. So next thing is to go ahead and head over to our Wireshark. I'm going to use sudo Wireshark for that. And I'm going to head over to the capture menu, interfaces. You can see I've got my ETH0 connected with 200.4 address. I'm going to go ahead and start that. So it's already doing some capturing. But I'm going to go ahead and stick a filter in here. Got a filter on the clipboard that I'm going to go to apply. So now we're not going to see any traffic in here until we actually sniff the FTP session, which will take place in a minute. So we're set up for capturing. We are capturing, but even though there's some packets going on in the network, we're displaying 0 because this filter only shows me traffic for my victim client, to and from my victim client. So we'll go ahead and head over to the attack here now and get on to a macflood command here. So I've got sudo macflood I for interface ETH0. This is going to start spitting out a zillion MAC addresses here and flooding the switch with a denial of service to buffer overflow. There we go. That's quite a lot of MAC addresses. Let's take a look over at our sniffer here and see what it says now. Okay, we've already got, in that short amount of time, about 90,000 packets sent over, so we should already be buffer overflowing here. You may remember that our switch only had about 8,000 capability, and we're already 150,000 and going up. No sniffed packets yet because I haven't started the FTP session on my victim client. But right now we're going to head over to the switch and just take a look at what the switch looks like here. So you may remember before that it had a total space available of 8,189. Let's take a look at what it shows now. I'm doing a show MAC address table count. Now it shows total MAC address space available 0, and we've filled up all the capability of the switch. So we're looking good to be able to go ahead and buffer overflow. If I was we are at a state of buffer overflow, but we're looking good for sniffing now. If I was a hacker, I obviously couldn't see this on the switch in my hack scenario here, but this is just educational for the video. So we'll head back over to Wireshark. You can see there's no packets being shown, even though we are now at almost 500,000 malformed packets being sent to the switch. We're still not sniffing anything from that host. So we're going to go ahead and get onto the victim client and go ahead and initiate the FTP session. So head over here to this guy, booted into DSL. Got the command already here, FTPing over to my victim server. And you can see it's asking for the username. And before we type the password, I'll just head over here to Wireshark here and see what it's got. Looks like Wireshark doesn't have anything yet. I'll go ahead and type this password. Oh, there we go. Took a second for Wireshark to process it, but it does now have the FTP. You can see user root, and now it's asking for the password. So it looks like Wireshark's keeping up with sniffing already. So the buffer overflow is working. Now we're going to go ahead and type in that password. And it looks like we're FTP'd in to our victim server from our victim client. Going back over to Wireshark in a second here, we should be able to see the password. It's a little bogged down with having almost about 800,000 MACs being thrown out, so it's going to take it a second here. In a second we should see our password for FTP come through successfully sniffed. One of the troubles with this attack is that it throws out so many MAC addresses that it does actually bog down the attacking box. So, and one thing you can do with that, as long as you're careful, is you can use the N option in macflood, a -N, and then specify how many malicious packets, malformed packets you want to send over. Just so you don't get so many going that you bog your machine down. We can actually, right now, even just go ahead and stop our MAC flooding, which is still going on, just so that we can give my box a break enough to go ahead and sniff that password. See if that comes through. There we go. There's the password. You can see the password came through. Pass super secret. So we successfully sniffed the password, which was unencrypted obviously because it's FTP protocol, which is a lesson to us all not to forget which one of our protocols are encrypted and which are not. And so we got the user root and pass of super secret. So the buffer overflow worked. Got the switch just spewing out traffic that was not really supposed to be heard by anyone else besides the ports communicating with one another, but the buffer overflow was able to circumvent that, and now we can listen for whatever traffic we want, including plaintext passwords on our victim boxes from the attacker. Enjoy!